In the previous video, we deployed a simple website using k3s. It was a non-encrypted site, and while that's fine and it works, it's very last century. In this video, we're going to install cert-manager and learn how to use it to deploy our websites using TLS. So our sites will be using HTTPS protocol. All of our web traffic will be encrypted, just like most modern sites are. The nice thing about doing it this way, we're going to be able to automatically obtain Let's Encrypt certificates, and we'll be able to automatically renew them when they expire without doing manual steps. So why are we using cert-manager? Traffic actually has Let's Encrypt support built in, but the way that it works, it stores its certificates in a file, which you have to mount as volumes and get to them that way. Cert-manager actually stores certificates as Kubernetes secrets, and in my opinion, secrets are easier to use because Kubernetes stores them automatically and we can reference them just by name. So that's what we're going to do in this video. Requirements for this video: you're going to need your running K3s cluster. You're also going to need a static IP and a domain name that you can create DNS records for. If you have a dynamic DNS provider that's supported by Let's Encrypt, that may work as well, but in this video we're going to use the former method, and we'll be manipulating DNS records via Cloudflare. The first task is to install cert-manager itself, and we're basically just going to go through the cert-manager documentation. We'll be jumping around a little bit because we're going to do very specific tasks. So we're going to go to install cert-manager. We're installing with Kubernetes. First step is to create the cert-manager namespace. So we'll just paste that in as kube control create namespace cert-manager. Now this just creates a namespace for the cert-manager pods themselves to run in. That way when you do a kube control get pods, you won't actually see the cert-manager pods running. The next step is to get the YAML config for cert-manager. Now in the documentation, they have you pull it down and apply it all in one step. Since we're running on an ARM architecture, we're going to have to modify the default YAML just a bit, so I'll show you how to do that. So we'll just use curl to pull down the file. And then we're going to modify this inline just to make life easy. I'm going to do sed-r, and I'm going to search for any line that has an image colon and a name, and then some version. And I'm just going to replace that with the same image name, but with -arm appended in the same version. We'll write that out to cert-manager arm.yaml. Just to show you what that did, we'll cat cert-manager arm YAML. We'll grep image. You can see there's 3 images here. In the file, they didn't have the -arm, the little set script that we just run, added the -arm, so that when we deploy this, we'll get the ARM version since we're running on the Raspberry Pi. So the next step is to simply deploy this to our cluster. It works the same way we've done it in the past. We'll do kube control apply-f cert-manager-arm.yaml, and it'll go off and create everything the cert-manager needs. We do a kube control get pods. Remember, it's in its own namespace, so we have to say --namespace cert-manager. See, a couple of pods are up. The one is still in container creating. That's actually it for cert-manager installation itself. But before we move on, let's do a quick overview of Let's Encrypt. The biggest benefit of Let's Encrypt is that it provides TLS certificates for free. You can do your home stuff, your hobby stuff, and you can get certificates that are just as valid as anyone else's, and you don't have to pay fees. The certificate process is automated, so we'll set it up so that these certificates are pulled and applied for us. They'll be automatically renewed before they expire. So the way this works, you request a certificate for a domain that you own. Let's Encrypt verifies that you own the domain by issuing a thing called an ACME challenge. There's 2 kinds. There's one that does it with DNS records. There's one that does it with HTTP validation. once it's verified, Let's Encrypt provides you with the certificate files. In this case, it's going to provide them to Certificate Manager itself. These certificates are good for 90 days, and then you have to redo the process. Again, cert-manager will do this for you. We're going to use the HTTP validation process in this video. It's a little bit simpler to use than a DNS process. So the way this works, cert-manager is going to issue a certificate request to Let's Encrypt. Let's Encrypt is going to issue an ownership verification challenge. The challenge is to put an HTTP resource at a specific URL under the domain name being requested. The theory here is if you can put that resource under that domain name and Let's Encrypt can get to it, then that proves you on the domain. Otherwise, you wouldn't have been able to put the resource there. So cert-manager will automatically put the resource there. It'll create a temporary ingress rule to allow incoming traffic to get to it. Let's Encrypt will then verify that the resource is at the challenge URL. If all that works out, then Let's Encrypt will provide your certificate files to cert-manager. Cert-manager will store those certificates as Kubernetes secrets. So I'm assuming in this video that you're actually doing this on your home network. As such, in order for these challenges to work, we actually have to configure our home network to let the challenges in. The big key is our requested domain name. It must route to our K3s cluster on port 80. We must be able to tell the world's DNS where that is. If you have a dynamic DNS provider, you may already have a domain name that they provide for you. That may work. I have not actually tried that. Or you can use a service like Cloudflare and enter DNS A records directly. And that's what we're going to do in this video. So for this next step, you actually need to know what your external IP address is. If you don't know what that is, you can go somewhere like whatsmyip.org and it'll tell you what your home address is. This IP address is your public IP address. This is the IP address of your router coming into your home out on the wider internet. So for the example in this video, I'm going to use a domain name of k3s.carpie.net. So I'm going to go to Cloudflare. I'm managing carpie.net, doing DNS configuration. I'm going to enter an A record for k3s.carpie.net. I'm going to put in my public IP address and then I'm going to click Save. Now be aware when you do this that DNS updates can take some time. So you want to check that this is resolving correctly before you proceed. You can do that with the dig command. So I'll do dig plus short k3s.carpie.net and I should get my public IP back. Now if you're using a service like Cloudflare, Cloudflare has the ability to hide your public address, so you might get Cloudflare's address there, but those will work as well. The key point is this has to resolve before you go on or your challenges won't work. Final step is to configure your router to forward port 80 to your cluster. Unfortunately, router configurations vary widely. I'll show you what it looks like on mine. I get to my local router by going to 192.168.0.1. The configuration I'm looking for in my particular case is under NAT and port forwarding. You can see I have forwarded port 80 to my cluster address of the KMaster 192.168.0.50. While you're in here, you might as well go ahead and also port forward port 443, which is the TLS or SSL port, to the same address. Not technically required for the challenges, but it will be required to get to our TLS enabled websites. So go ahead and do that as well. Now we're ready to create configuration files for the Let's Encrypt issuer. We'll get the template for this from the cert-manager documentation site. If we go under the ACME issue tutorials, we can actually skip to step 6 because we've already set up cert-manager itself. We just want to configure the issuer. The first thing we're going to configure is the staging issuer. It chooses the Let's Encrypt staging site, and this will let us work out any kinks that we have in the configuration, because if you try to work those out against the production site, they will cut you off very quickly. So let's copy the configuration here into a file called Let's Encrypt-issuer-staging.yaml. Paste it in. We will be making a few changes. We're going to change from issuer to cluster issuer. The only real difference here, the cert-manager issuers issue in a specific namespace. If we use the cluster issuer, we can issue in any namespace. So we get on here, the staging address is correct. You have to put in your own email address. This is how Let's Encrypt communicates with you. They'll tell you if things have gone wrong or if you're doing bad things to the server, that kind of thing. We're going to use the HTTP1 solver. We're not using Nginx ingress, we're using traffic, so we'll change that. Once we save that, we'll deploy that like normal. Kube control apply-f, let's encrypt issuer staging.yaml. You can see that that has been created. We do a kube control get ClusterIssuer, which is a new type defined by cert-manager. We can see that that is now set up and good to go. So we set the challenge solver, we're using HTTP1, so we created the cluster, so all that's been done. So what we want to do now is manually get a certificate just to test this out. This is not the way that it's going to work in the future, but we want to make sure that everything is right before we move on. So if we go back to the documentation and we click on issuing an ACME certificate using HTTP validation, we're just going to get the certificate request YAML, create a file, le test certificate.yaml. We'll paste in the certificate information. We'll call it k3s-carpie.net. We're going to store this in the Kubernetes secret name of k3s-carpie-net-tls. And then the common name is our domain name that we want, which is k3s.carpie.net, and that is also the DNS name. One extra change here, since we're using ClusterIssuer instead of issuer, we need to tell it, so we'll say kind ClusterIssuer. To request a certificate, we just do our standard kube control apply-f to the le test certificate.yaml. And we can see that the certificate is created, so let's take a look. Kube control get certificates. So we can see we have the certificate k3s-carpie.net. Ready true means it's already done all the procurement of the certificate, and it is stored in the secret k3s-carpie-net-tls. We can look at that with kube control describe secret k3s-carpie-net-tls. You can see we have TLS-CRT and TLS.key. So that worked. That's a happy path, but this is a place where things can commonly go wrong. If you don't have things set up right, or you made a typo, or your forwarding doesn't work. So I just want to take a few minutes here and show you how you can troubleshoot this if things do go wrong. So I'm going to copy my test certificate to a bad certificate, and the problem with the certificate will be it's a domain that I don't actually own. So I'm going to change this up. I'll call this bad-carpie.net. And update all the names to be that. Now, I haven't put in a DNS record for bad.carpie.net, so this is not going to resolve. I'll do kube control apply-f to request the certificate. Now, if I do kube control get certificates, we can see we have bad-carpie.net, but ready is false. Okay, now that could be that just because it hasn't had time to do the procurement. If we look at it again, it's still not ready. Maybe something's wrong, so we should troubleshoot it. So we'll start with kube control describe certificate. Kind of look through this. This kind of looks okay. It's waiting on a certificate request. So let's look at the certificate request. We'll say kube control get certificate request, and the name of the certificate. Okay, that didn't tell me a whole lot. Let's try describe instead. Okay, so this says it's waiting on a certificate issuance from an order, default bad.carpie whatever. So let's do a kube control get orders. We can see there's the order that's still in a pending state. So kube control describe orders and the name of this order. Okay, so we see that in the end, the last status of this was creating a challenge resource. So let's look at that. Kube control, describe challenges, and the name of the challenge. Oh, and then we come down here. Finally, we find the reason. It says it's waiting for the challenge propagation. It failed to perform self-check. The GET request resulted in no such host. So that's what actually went wrong with this request. Now we expected that in this case because we don't actually own that domain name. So when Let's Encrypt tried to get to that HTTP resource, it couldn't find it because the DNS system wouldn't route it to our K3s cluster. So you can use this general process to go through all the records and figure out why your certificates are not working. Since we know that this one is bad, I'm just going to go ahead and delete it. I'll do kube control delete certificate bad-carpie.net. That should clean that up. And the other certificate was good, but it was kind of a test certificate. We actually want to use that same name though when we deploy our site, so I'm going to go ahead and delete that as well. Kube control delete certificates k3s-carpie.net or -net. We also want to clean up the secrets that were created by those. Those you have to clean up manually. So we'll say kube control delete secret k3s-carpie-net-tls. And let's check just to make sure. We'll do kube control get certificates, and there are no certificates. Kube control get secrets. Oh, we left the bad secret. So we'll do kube control delete secrets bad-carpie.net. And now we're good to go. Okay, so we got Let's Encrypt staging set up, and we were able to successfully grab a certificate, so we know that things are working. So now we want to create the cluster issuer for the production Let's Encrypt. We can copy the staging YAML over to a production YAML, and we just have to make a few changes. We'll call it Let's Encrypt prod. We'll take staging out of the server URL, and then the name will change to prod, and everything else is the same. We can save that, and then we just apply that as normal. Kube control apply -f, Let's Encrypt issuer production.yaml. Just check it with kube control get cluster issuers. Now you can see we have staging and we have prod. So now we're ready to request a certificate for our website. It's important to note that all the steps that we've done up until this point are one-time setup. We have cert-manager set up, we have an issuer for Let's Encrypt production, we're good to go. So from here on out, anytime that we need a new certificate, you can kind of follow along from here. So we're going to request a certificate for our website. All we really have to do is just modify our site YAML files to request the certificate. So let's modify the website that we deployed in the last video to use TLS. And I've deleted it from my system, so I have to recreate it. If you've deleted it, you'll have to do this as well. If you left it, then you can just keep what you have. So I'm going to recreate that config map, kube control create config map, my site HTML. From file index.html. Now we can update our YAML file. This should be familiar to you from the last video. The only thing that we have to add is in the ingress rule, we're going to add a TLS record. We're going to say hosts. In this case, we have one host, k3s.carpie.net. We're going to use a secret name of k3s-carpie-net-tls. And remember, this is the secret that was written by the cert-manager when it went out and got our certificates and stored them in this secret. So under annotations, we're going to tell the ingress record that we want cert-manager to use the cluster issuer let's encrypt.prod. So what's going to happen here is when we deploy this ingress record, K3s is going to look and say, oh, you're using TLS for host k3s.carpie.net. Oh, you're using the secret k3s carpie.net-tls. That doesn't actually exist, so I need to go create that. It's going to go up. It's going to say, oh, you're using let's encrypt.prod issuer. It'll go issue the request for the secret. It'll store it in k3s carpie-net-tls, and it will install the certificates that result from that request. So now all we have to do is just redeploy the site. We'll use kubectl apply-f mysite.yaml. Give it a little time to spin up. And then we'll check it with kubectl get pods. You can see that it's running. Since this is our first time, let's manually check the certificate. If we do kubectl get certificates, we see k3s carpie.net-tls, and we see that it is ready as true, which is a good sign. So let's go over and try it out. If we go to https k3s.carpie.net, there's our site. It's nice and secure. You can check the certificate. We have a valid certificate issued by Let's Encrypt. We're good to go. Our K3s cluster has more capabilities now. We can deploy TLS websites. We can deploy anything really that needs a certificate and have those certificates automatically provisioned. Very cool. So we want to get more complex, and when we get more complex, we're going to want to build our own images. But before we can build our own images and actually use them, we need a place to store them. In the next video, we'll explore how to set up our own secure Docker registry to store our images. That's all for this video. Thanks for watching. If you like this video and would like to see more, please consider subscribing to my channel.